On average, here's a question, on average 70% of people pass their driving test the first time. There are complaints that Mr. Keeler is too harsh, which is a bit stupid seeing as I can't drive, but there we go. It's a bit harsh, and so unknown to himself, his work is monitored. It is found that out of 20 candidates, he failed 10 of them. Formulate a null and alternative hypothesis and test at the 5% level. Okay. Now, we've got to decide on a number of different things to set up the test here. The underlying distribution is binomial. Okay, so let's first of all, let's try and get the binomial bit sorted. Then we'll do the test, and then we'll formulate the test, then we'll do the test. Okay, so first of all, I'm going to make x. Well, what am I going to make x? The number of people who, hands up. Number of people, AJ?
Number of people who fail or pass?
Well, it doesn't really matter. 70% of people pass, so I'm inclined to say number of people who pass. Okay, number of people pass. Spencer, what is n? 20. Okay, we've got 20 people who have taken it. Now, this is crucial. Your probability of success. Now, in this particular sample, 10 out of 20 of them happen to pass. Or 10 out of 20 failed, so 10 out of 20 passed, yeah? Now, some of you are going to be inclined to write 0.5, because 10 out of 20 is 0.5. Why is it not 25, 0.5, and what should be the correct probability of success here?
Isn't the 70% at the top?
Yes, why?
Because that's the likelihood you'd pass.
Yes. Now, so when we're setting up the test and everything else, we have to look at the kind of theory. We're putting probabilities, which are theory here. The underlying theory says, on average, 70% of people pass. Okay, that's what we think. That's the normal state of affairs, yeah? So P is 0.7. Q, the probability of failure, is what, Beth? 0.3. Okay? So this is, X is modelled by a binomial distribution, N is 20, and P is 0.7. Okay, so this is the underlying distribution. We've sorted out the distribution. This is what it is. Okay? And we use the 0.7 from the theory. The question is the kind of theoretical probability. Now we have to set up the hypothesis. Right. Anybody tell me what would we write first? What do we do first? What's the first hypothesis? H0. What does H0 mean? What is that? What is the possible? What do we call that? Null hypothesis. Can anybody tell me what is the null hypothesis? What do we write from the null hypothesis? Harry. What we expect. Now, it's always going to be a probability P. So what do we expect the probability of someone passing to be based on the theory? What would we expect on an individual person? What would be the probability we'd expect it to be, Sam? 0.7. The null hypothesis will always be a probability equal to something. It's not going to be less than or larger than. The null hypothesis, the probability will always be equal to your theoretical probability in the binomial distribution. No ifs, no buts. Right, the H1 is the alternative hypothesis. This is what we're trying to prove. Now, I'm going to have P there, I'm going to have 0.7 there, that will have to be true for every single hypothesis test. You know, the same bit, same numbers, same that P. But what is different is what goes in between the P and the 0.7. Can anybody tell me what are we trying to say here? What are we trying to prove? Joe?
We're proving that he's too harsh, that he's failing too many.
Yeah, so what would it... Less than, yes. The question says, Mr. Keeler is too harsh. Now, if he's too harsh, the probability of someone passing under him would be less than 0.7 if he was too harsh, yeah? Okay. The significance level, they give you that in the question, is 5%. Okay? Yes, Regan?
What would you do in a situation where they don't give you the significance level?
They would always give you a significance level. Unless they might say, what significance level will you pass the test, what significance level will you fail the test. If you're doing the test, they'll give you the significance level. Okay? Right, that's our test, that's our next section done. That's our test sorted. Okay? Now we need to apply the test. Now, so far, we haven't mentioned anything about the 10 out of the 20 people. This is what actually happened. This is like the experiment. We've done the experiment with 20 people, and we found that 10 out of the 20 pass. Okay, so we're going to work out the probability that x, now, is it less than or equal to 10? Or is it larger than or equal to 10? Why is it less than, Frank? Yeah, we're testing if it's harsh. If it's harsh, I mean, yeah, he failed 10, but he could have failed less than 10 as well. You'd still count him as harsh. The clue is, remember, the clue is, here we've got a less than sign there, so we're going to have a less than or equal sign there. That's how I always remember it. It doesn't really help you understand it, but as a way of remembering whether you work out less than or large than, we always look at the alternative hypothesis and look at that. That's a way of which I know if I'm doing it right. Now here, we can get the less than, it's perfect really, less work, because we can get these directly from the table, can't we? We can get these directly from the table. So, if you get your table up, I'm going to go all programs, Internet Explorer, and I'll type in MEI statistical tables. And we're looking at n is 20, p is 0.5. So there's the n is 20. I'm going to zoom in a bit so you can see. P is 0.7. Actually, I've gone a bit too far. Right, it's going to be right at the edge there. So let's just. So we're dealing with. Can we just concentrate, please? We're dealing with these numbers here, aren't we? P is 0.7. This is n is 20. You have n is 20. Okay, we're after less than or equal to 10. Right, so it's quite a bit of a mission to kind of go through this, but it's going to be this number here. Okay. So the probability that x is less than or equal to 10 is 0.0480. So we get back to that. You know, I've forgotten already. 0.0480. That's it. So we've calculated in that sample the probability of him doing failing 10 out of 20, based on the fact that if we assume that the probability of someone passing is 0.7, is 0.0480. What do we do now? What does this tell us? What do you notice about this probability? Big, small? Small. Is it small enough? Jack, why? Yes, 0.0480 is less than our significance level of 0.05. Sorry, I forgot to mention 5% of 0.05. This probability is smaller than what we accept would happen for chance. We're saying the chances of him having 10 or fewer students fail is so small that it probably didn't happen by chance. We're saying, in other words, that he is harsh. Because our probability is less than the significance level, we accept H1. And this means that we have to write a sentence saying this: there is evidence to suggest that Mr. Keeler is too harsh. We can't say it for sure. We can't say it for sure if he's being too harsh, it's just one sample, but there's evidence to suggest that perhaps he could be, because the probability of him failing 10 or less students is tiny. Tinier than our accepted significance level. Okay? What's interesting about this is, let's say we changed our significance level to 2.5%. 0.025. Now this means, if we were doing the test again, the probability would stay the same, but this would be, well, it would be completely the other way around. It would be larger than 0.025, which means we wouldn't accept H1 because our probability is bigger than our significance level. We'd actually accept H0, and he would be all right. He would be all right. We'd be able to say, actually, no, there isn't enough evidence to suggest he's being harsh. So, this significance level is the pure crux of the matter. This significance level is vital for tests going either way. And Mr. Keeler, the driving inspector, if he was being told that he was too harsh, he would perhaps argue, okay, well, why was it a 5% significance level? I want it at a 2.5% significance level. Then I pass the test. Then you can't prove that I was being too harsh. This significance level is crucial, and that's why I said this is proof with inverted commas, because it's statistical proof isn't like a mathematical proof where we can prove that yes or no, 100% completely or not. This is still a subjective proof because of that significance level. Any questions?